Hey, so in this lesson we're going to look at how to solve an equation with 3 variables and 3 equations, so a system I guess with 3 variables and 3 equations. So when we were looking at 2 variables and 2 equations, we knew we had to find the x and the y. This time, since there's 3, we're not going to be done until we actually find the x, the y, and the z. So we still need to find all 3 variables. Okay, we could try it by graphing. That's the way we started with the 2 variables, but graphing on a 3D graph is a pain, so let's not. We could try it by substitution, and these are solvable by substitution. It just takes a really long time and a lot of space. So we're going to skip that and see if we can solve it by elimination/addition. So we're going to start off by picking a variable. Pick a variable that you think will be easy to eliminate, and see if you can eliminate it from 2 of your equations. So we're going to look at my first 2 equations. If I look at my first 2 equations, the easiest variable to eliminate is the z. I don't actually have to change anything to eliminate that z. So I'm going to rewrite everything. And get 3x plus 2y plus z equals 8, and 2x plus y minus z equals 3. If I add them to eliminate the z will cancel out, and I will get 5x plus 3y equals 11. Okay, so that's good, and now I have one equation with an x and a y. This is what we've been working with. We've been working with equations with an x and a y. So let's see if I can find another equation with an x and a y. So what I'm going to do is look at my bottom 2 equations and see if I can eliminate the z again. I eliminated the z up here, so I'm going to see if I can eliminate the z in the bottom 2 equations. You don't have to do it with the bottom 2. You can do it with the first and the third if you want to. And I just like keeping everything kind of layered up. Okay, so if I eliminate the z in the bottom 2, that means I am going to have to multiply through by a -1, so that way I get the opposite sign, same number. So I'm going to recopy the bottom 2, so I'm going to bring it down here. Top equation, I'm not even changing. I'm going to keep it 2x plus y minus z equals 3. And if I multiply the second one through by -1, I will get -1x plus 2y plus z equals 4. Okay, so if I add them, my z's again cancel out, which is good, so I just get x plus 3y equals 7. Okay, so now I have 2 equations with 2 variables. This is what we were working with before. So I have the 5x plus 3y equals 11, and x plus 3y equals 7. I can solve this. I'm going to solve it again by elimination, so again I'm going to have to multiply one of my equations by that -1. So top equation again, I'll just recopy. Bottom equation, in order to eliminate something, and y's were easiest, and multiply through by -1. -1x minus 3y equals -7. Combine like terms. My y's cancel out, which is what I wanted, so I get 4x equals 4, and x is going to equal 1. Again, I'm not actually done. I am not done until I find all my variables. So I found my x equals 1. Let's go ahead and see if I can find my y or my z. Looking at this, going backwards, is going to be pretty easy for me to find my y. I can just substitute my 1 into either of my previous 2 equations. So I can take my bottom equation here, my x plus 3y equals 7, and I can substitute 1 in for the x and get 1 plus 3y equals 7. 3y will equal 6, and y will equal 2. So I could find my y pretty easy by working backwards. Let's work backwards one more and see if I can find my z. So again, I can substitute it into any of my equations. I'm just going to choose my bottom one for no good reason at all. And I'm going to sub in. My equation was x minus 2y minus z equals -4. So 1 minus 2, y was 2, so times 2, minus z equals -4. 1 minus 4 minus z, so -3 minus z equals -4. Negative z is going to equal -1. Z is going to equal 1. Okay, so I'm going to want to go ahead and check this to make sure this is the right solution for everything. So by checking it, I can substitute into all of my original 3 equations to make sure it works. If I substitute into the top one, I'll get 3 times 1 plus 2 times 2 plus 1. Does that equal 8? 3 plus 4 is 7. 7 plus 1 is 8. So it works. Sub into my second one. 2 times 1 plus 2 plus, well, in this case actually minus 1, sorry, that was a minus z, equals 3. So 2 plus 2 is 4, minus 1 is 3. So that works. My last one should work, that's how I found the z, but let's just check and make sure. 1 minus 2 times 2 minus 1, does that equal negative 4? 1 minus 4 is negative 3, minus 1 is negative 4. So it works for all 3 equations. So this is my correct answer. Let's try it with the second one over here. So I have 2x plus 3y minus 2z equals 1, 3x minus y plus 4z equals negative 7, and x plus y minus 3z equals 5. Again, I'm going to look and try to see what variable would be easiest to eliminate between all 3 equations, so going in pairs of 2. If I look at it, it looks like my y would involve the least amount of work. I already have the negative 1y in my second equation and the positive 1y in my third equation. So I'm going to eliminate the y's. I'm going to do the same thing I did before, work with my first 2 equations first. So in order to get the same number opposite signs, I'm going to multiply a 3 times that second equation. That way I'll have a 3 in front of the y and a negative 3 in front of the y. So top equation, I'm just going to recopy 2x plus 3y minus 2z equals 1. 9x minus 3y plus 12z equals negative 21. Check, my y's will eliminate, so if I add, I'll get 11x plus 10z equals negative 20. Okay, so I got one equation with 2 variables, so that's good. I'm now going to look back to my original 3 equations. I'm going to take my bottom 2 and try to eliminate the exact same variable, so try to eliminate the y's. This time it's going to eliminate pretty easily. I don't have to do anything to either of the equations, since one of them is already a minus y and one of them is already a plus y. So I'm just going to recopy. If I add then, my y's do cancel out. I always want to check that and make sure. So 4x, 4z and 3z will be plus z equals negative 2. So again, I'm going to take those 2 equations with 2 variables and recopy them right next to each other, right on top of each other, so I can try to eliminate one of these variables. That was an x. So 11x plus 10z equals negative 20. 4x plus z equals negative 2. Okay, so if I look at these variables, my z seems easier to eliminate. So I have a positive 10 in my first one, a positive 1 here, so I'm going to multiply my second equation by negative 10. So my top equation will stay the same, 11x plus 10z equals negative 20. Bottom equation should be negative 40x minus 10z equals positive 20. Combine like terms, I'll have negative 29x. Z's will cancel out, always check that. In this case, my constant on the other side cancels out, so I have negative 29x equals 0. Divide both sides by negative 29, x should just equal 0. So I have one part of my solution. I have x equaling 0. I still need to find the 2 other parts. So working backwards, it seems the next one that's going to be easiest for me to find is my z. So I'm going to substitute the x in, substitute into the second equation, so 4 times 0 plus z equals negative 2. So that 0 term will just disappear basically. So z equals negative 2. Okay, working backwards, I'm going to find my y. Again, I'm going to plug into the third equation. So x was 0 plus y minus 3 times negative 2 equals 5. So y plus 6 equals 5. Y should equal -1. Sub it in to check. So let's see, if I sub it into the first one, 2 times 0 is 0. 0 minus 3 is -3. -3 minus 2 times -2 is +4, so -3 plus 4 is 1. Checks there. Second one, 3 times 0 is 0. Y was -1, so +1 would be a +1. And then -8. 4 times -2 would be 8, so -8 would be -7. +1 minus 8 would be -7. So these three should work out.